Alright, in the last video we learned how to graph a quadratic function that was in standard form by completing the square. There is another way that you can graph without completing the square. So we have our equation f of x equals ax squared plus bx plus c. That's in our standard form. And we can use the vertex formula here to find the vertex without completing the square. So this is an ordered pair. Okay, and negative b divided by 2a, that's going to be our x value. And whatever we get for x, we plug into the function, and that's why it says f of negative b over 2a. And that's going to be our y value of the vertex. So what do I mean? Alright, so it says graph f of x equals negative x squared minus 2x plus 8. So instead of completing the square, I'm going to use that vertex formula. I'm going to find the x value of the vertex by doing negative b over 2a. In this case, a is negative 1, b is negative 2, and c is 8, right, from this equation. So negative b when b is negative 2. So negative 2 would make positive 2 over 2 times a, which is negative 1. 2 times negative 1 is negative 2, and 2 divided by negative 2 is negative 1. So that is half of our coordinate. So our vertex will be negative 1 something. And I can find the y value by plugging x equals negative 1 into our function. So f of negative 1, plugging in negative 1 wherever we see an x, into our original function here. So negative 1 times negative 1 is positive 1, but then we have this negative on the outside. So inside, when we square it, it becomes positive 1. Negative on the outside is negative 1. Negative 2 times negative 1 would be positive 2. And now we've got negative 1 plus 2 plus 8, which will be positive 9. So that's our vertex, negative 1, positive 9. So again, f of x is the same thing as y, so this is giving our y value here. Alright, and it also says to find all intercepts and the line of symmetry again, so that's the same. I plug in 0 for x to find the y-intercept, 0 for y to find the x-intercept. So f of 0 equals negative 0 squared minus 2 times 0 plus 8. 0 squared, 2 times 0 is 0. So f of 0 is positive 8. So that's an ordered pair. We plugged in 0 for x, got out 8 for y. Then for our x-intercepts, we plug in 0 for y. F of x is y, so 0 equals negative x squared minus 2x plus 8. So we're going to try to factor before we do anything else to see if it is factorable. Our leading coefficient here is negative 1, so we're actually going to pull that out as the GCF. Right? We want our x squared term to be positive. So when I divide everything by negative, negative 2 becomes positive 2, positive 8 becomes negative 8. Now I want something that's going to multiply to negative 8, but add to a positive 2. So I'm thinking 4 and 2, and the negative needs to go with the 2 to add up to positive 2. So I still have my negative 1 out front, but my leading coefficient inside those parentheses is a 1. So I go into x plus 4 and x minus 2. That means that x could be negative 4 or a positive 2. So those are two separate points again at negative 4, 0 and 2, 0. Right? They are the x-intercepts. Alright, so now I can graph this stuff. I'm going to start with the vertex at negative 1, 9, and that's going to go off my graph. So -1, and then 1, 2, 3, 4, 5, 6, 7, and then 8, 9. So it's going to be up here, and I apologize, it's off the graph. Okay. Just kind of continuing that line out for us. And then the y-intercept is going to be at 0, 8. So that would be over here. And it's going to be symmetrical, so there's going to be another point over there. And then the x-intercepts are at +2 and -4. 1, 2, 3, 4. And notice the graph is going downwards. And that makes sense because our a was negative. So the graph should be going down. If it's not going down, then we did something wrong. Alright, and there you have it. So now we can use the vertex formula to find the vertex, and then still plugging in 0 for x to find y, 0 for y to find x, and then we can graph it. Oh, and the axis of symmetry. So the axis of symmetry goes through the middle of the graph, and it's cutting through the x-axis at x equals -1. So that's the axis of symmetry. Why don't you guys go ahead and try the next example and see how you do. Okay, so we're trying to graph f of x equals 2x squared minus 4x minus 1. And we're going to use the vertex formula. So x will be -b over 2a. And we identify a as 2, b is -4, and c is -1. So -4 would be +4 over 2 times a is 2, and 2 times 2 is 4. 4 divided by 4 is 1. Now that we have the x part, we can find the y by plugging in 1 for x. So 2 times 1 squared minus 4 times 1 minus 1. 1 squared is 1, and 2 times 1 is 2. 4 times 1 is 4. And we have 2 minus 4 minus 1, which will give us -6 plus 2, or sorry, -5 plus 2 is -3. And so that's our vertex. It'll be at 1, -3. And then we can identify our intercepts. We're going to let x equal 0 to find the y-intercept. So f of 0 is 2 times 0 squared minus 4 times 0 minus 1. So notice here, every time the a term and b term get multiplied to 0, because we're plugging in 0 for x, and the y-intercept is always c, and that's always going to be true. So f of 0 equals -1, and we get the y-intercept of 0, -1. So that will always be the c, the constant. And then we let y equal 0 to find the x-intercepts. So we're plugging in 0 for y, and that's 2x squared minus 4x minus 1. So first we try to factor. We say, okay, we have a leading coefficient of 2 here, so we have to multiply a times c. So we want something that is going to multiply to -2, but add to -4. Well, the only factors of 2 are 1 and 2. And there's no way to make those add up to 4. So this one is not going to be factorable. Okay? So if it's not factorable, we have to use the quadratic formula. So again, that's our backup plan. You could also complete the square. I find that most students prefer the quadratic formula. Alright, filling in our quadratic formula, x will equal -b, which will be +4, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So let's simplify what's under this radical. So 4 times 4 would be 16, and then we'll have negative 4 times 2 times negative 1. So a negative negative will make it positive. 4 times 2 times 1 would be 8. So we'll have 16 plus 8 under the radical. So we'll end up with plus and minus under here. 16 plus 8 is 24 over 2 times 2, which is 4. Let me write that a little bit better. If you're asked to leave this in exact form at any time, we need to simplify that radical. This is 4 times 6, and 4 is a perfect square. 6 is not, so we can take out that 2. So this would be 4 plus and minus square root of 2 squared is 2. And we still have that 6 left underneath, all over 4. And then we can divide out a common factor of 2, right? It only works if all 3 terms here have a common factor, but 4, 2, and 2 are all divisible by 2. So I end up with 2 plus and minus. 2 divided by 2 is 1, and 4 divided by 2 is 2. So that would be the exact x-intercepts. But you also are trying to graph it here. So I don't know what that is in my head, so I'm going to need a calculator. And I'm going to get the approximate values. So I'm going to start with this square root of 6. So there's the square root of 6. I'm going to add 2 and then divide by 2. So approximately 2.2. So x is approximately 2.2 for one intercept. And then we're going to do it again for the negative. So square root of 6. And then we want to have the negative square root of 6. So I'm going to negate it. So now it's negative square root of 6. Plus, it's still positive 2. And divide by 2. So this is negative 0.2. I'm just taking it out to the tenths. Honestly, we can't really graph by hand anything smaller than that. Alright, so now I've got my x-intercepts, got my y-intercept, and I have my vertex. So I start with my vertex at positive 1, negative 3. 1, 2, 3. I have my y-intercept at negative 1 on the y-axis, and my x-intercepts are decimals, so approximately 0.2, negative 0.2 here, and positive 2.2, so 1, 2.2 over here. Obviously this is just an approximation because I'm doing it by hand. And then this is also going to be symmetrical, so I know there's going to be a point there. And then I connect my dots. And there I go. I have my graph. And the axis of symmetry, again, just cuts it right down the middle. So in this case, it'll be at x equals positive 1. All right. When you're graphing these sorts of things, if you wanted more nice points, so you didn't like this value here, you can always make an XY chart and then just pick some x values like negative 1 and 4. You know, any value that you plug in, any whole number that you plug in here, you're going to get out a whole number as well to find some more nice points on your graph. All right, I hope that helps.